Recording has started. Hello, everyone. Welcome to another Hydra working group session. I believe, I don't know when it's going to be next, but seems like we're going to have this one and then probably one before end of the year, and that's it. This is pretty much our almost last touching point. Closing the year.
When do you guys leave for
makes sense.
Christmas holidays? What's the time when do you usually leave? Like until what date they're usually working? Because I don't know, because I'm not. I celebrate like Orthodox Christmas, which is behind yours.
So I think normally people in the other calendar, they celebrate Christmas December 26th. So they usually take time off anywhere between December 20th and January 3rd or something.
Yeah.
So, yeah.
Nice.
There's still some time.
Yeah, there's still some time. I mean, personally, I'm probably going to be doing at least a little bit of work during the holidays, because that's when everything is quiet and I don't have to attend any meetings. So that's when I can get some stuff done, actually. Other than the specific dates of, Christmas Eve and, Christmas Day plus New Year's Eve. Obviously, those are off limits, but the days in between are usually very nice.
Yeah.
Because you have all the leftovers as well, and
Exactly.
you don't need to cook. There is abundance in alcohol. Sounds like a great golden night for me.
Yep.
So
hey, so let's kick off the discussion. I actually have something to raise. I was reading the Hydra spec, the one that you have posted on the website recently, and to be honest, I mean, I understand the Hydra design and stuff, but you guys, there's a bunch of UTXO set hashes all over the place, new delta, new alpha, new omega or something.
Yeah.
But to be honest, it gets a little bit confusing. So I was wondering if you could kind of help decipher them a little bit.
Yeah.
And why they exist.
It's going to be also a bit different now after the incremental commits. Just today, we found some bugs, and in order to solve it in the most easiest way, is just being more explicit in code and also in the spec. I guess you got confused about the delta one, the delta UTXO hash.
Yeah, because sometimes these news aren't really defined in the spec, right? It doesn't say, okay, this new, I don't think I saw what new delta is defined to be. And also new prime, right, when there's a transition, is not explicitly defined, right? So I assume that new prime, if there's an increment, it's the union, essentially, of, the old new and the new alpha or something, right? And similarly for decrement, new prime would be the set difference between the old new and new, whatever the new is for decrement, right? Is that correct?
Well, I don't remember this new prime thingy, but the delta, the delta hash should be the difference between currently. Let's talk about this as the incremental commits do not exist, because it's a bit easier. And this is just a hash of this additional UTXO you perhaps want to fan out in the end. So, for example, if the decommit, you try to decommit, and that actually didn't happen, but you have a snapshot that has something in that field reserved for the decommits. Then on fan out, you do like a normal. There is a list of outputs that you normally want to fan out, and if there was something to decommit in the snapshot, but you actually didn't do it, you just provide it as a way to satisfy the signature, so that the snapshot signature matches, but in the end, you're not actually going to have this as the output. It's a bit confusing. We will also do. We need to do more work on the spec, especially now with these incremental commits on the way, and it's going to be a bit more explicit. But maybe it's going to be easier, because right now I'm trying to. How I'm approaching it is to just have these things separate. So there will be like alpha UTXO hash, which is stuff you want to commit, and then omega UTXO hash, which is stuff you want to decommit. And its purpose is just to be there, usually just for providing the correct signature. But and I mean, as far as I can remember, that's it. It just.
When do you merge the incremental commits into the active UTXO set? Does that happen right away in the increment transaction? So that, new, if new is the old UTXO set, the active UTXO set, and new prime is the new active UTXO set, then new alpha, which is the UTXO being committed, is not a member of the old UTXO set, but is a member of the new UTXO set. Is that how it works?
Well, I mean, it should be the case that we maintain only one UTXO set, and these hashes you mentioned, there should be there just for providing so to be
they're
able
just
to.
in the redeemer, yeah, for the signature, right?
No, they actually live in the datum. We do sometimes provide some additional data in the redeemers, but this, for example,
why do these increment and decrement hashes need to live in the datum?
So, I mean, there's no specific reason why they should be in the datum. They could also be in the redeemer. But we need, for example, for the fan out, we take a look at the closed datum, and we say that any UTXO hash, for example, in the closed datum needs to match with the outputs we want to fan out. And so it's kind of I don't know, maybe convenient to also keep the delta UTXO hash also in the datum, and that way you sort of, when you close ahead, you're sure that the information you have in that datum is the one you're using in the fan out.
Yeah, that was another thing I was a little bit confused about. Why are there 4 cases, 4 scenarios for closing? I think they were called something like unused increment, unused decrement, used increment, used decrement, or something.
Yeah. We wanted to
What do they
distinguish.
mean?
So it means like you can try to decommit or to commit something, but that takes a bit of time, and in between somebody can decide to close the head. So this is our way of trying.
So incrementing and decrementing are both 2-step processes.
Well, no, the decrement happens as sort of. I mean, it is a 2-step because you first send out like a network message, and then everybody sees that message, and then you actually decommit. For the commit, you need to deposit, and then afterwards you actually do the increment. So in both cases, can happen that you maybe sign a snapshot, you want to do something, and then the head gets closed. So you need to distinguish, like, did this thing happen or not? Because if, for example, you wanted to increment something and you didn't, that's all good. Like, you don't need to fan out anything special because you didn't include this UTXO to the head. And in case of decommits, you can also say, like, yeah, I have a snapshot that says that I want to decommit something, but I actually didn't do it. And then on fan out, you're supposed to not take this into account. You're just supposed to fan out everything that was in the head. But the snapshot signature depends completely on the snapshot. So we need to have a way of providing the correct signature on chain for the snapshot you use to close.
Yeah,
I mean,
so I understand why increment has to be two-step, because basically first the user has to send the funds in on L1, and then the head has to recognize the fact that these funds were sent in and that it's absorbing those funds, and representing them in the L2 ledger. I don't really understand why decrement has to be a two-step situation, because a decrement message on L2 is just an event. It's an event just like a transaction. So as soon as it gets included in a snapshot, just like a transaction would, its effect should already be accounted for, right? So essentially, you set aside the decremented UTXO. It cannot be spent by any subsequent L2 transaction, but it is allowed to be withdrawn, on L1 by referencing its, membership in the withdrawn UTXOs, right? To me, that seems like it should fundamentally be a one-step process, essentially, right? Because you just need to include it in a snapshot, and then your job is over.
Yeah, but you also need to reobserve it back to know that the decommit transaction went through. And we do
On
this.
L1?
Yeah. So it can happen that for some reason you try to decrement, you sign the snapshot and everything, and then you just don't observe that the decommit transaction back, and you don't actually know if the thing went through or not. So if on fan out you need to still provide this UTXO, or you can say that this decommit UTXO is already on layer 1, so you don't need to output it again on fan out. And
I see. So the decommit settlement transaction on L1, basically, instead of modifying the active UTXO set in place or something, it grows the tree of the decommits that have already been executed, so that you can't really double spend, right? Essentially, out of the head.
It happened sort of sequentially. So what we do right now, because we want to keep things simple, is that you can always do only like one decommit at a time or one commit, and that's exactly right. So you need to decide on fan out what you actually want to fan out and what should not be double spent. And for that to work,
yeah, that makes sense.
Yeah, we have some we keep some things in the local state, like we call it versions. So when you try to decommit, we see a snapshot, we say, okay, we'll bump the version to like +1 locally. And then when we reobserve the decommit, we say, oh, okay, now the version is actually, should be sort of equal between the snapshot version and the local version in the state. So that's the only way we can detect if something happened or not.
Yeah, kind of introducing some account semantics to the Hydra head.
Yeah, it's a bit pain in the ass, to be honest, because it's a bit, I don't know how to say. I sort of think that maybe there is a better design for this. It's gonna work, but I'm not sure how will it behave when we try to do more things like maybe do like batch commits and decommits and stuff like that. It feels a bit fragile, to be honest, but yeah, let's see what happens and how it works in the end.
Yeah, I kind of sidestepped this whole problem in Hydrazoa because in my case, everything is a native script. So if you want to absorb commits or deposits, essentially, I call them deposits now, you just have a multi-sign transaction that just absorbs the deposits. If you want to release withdrawals, which you call decommits, you just have a multi-sig transaction that just releases withdrawals. And then if you're unable to produce any more multi-sign transactions, which means that communication off-chain has broken down, right, and there's no more consensus, or consensus is stalled, then I use a clever timeout trick to transition control from the native script to a UPLC script, which can then handle the dispute resolution process to select what is the latest snapshot. And then the latest snapshots, the latest snapshot includes Merkle root hash of all the active UTXO set, right? And once that's settled, like the dispute resolution is settled, then you can just simply withdraw from the Merkle root hash by the usual standard operations of proving membership and then modifying the tree, that whole thing.
Yeah, let's see. I mean, it's sort of, I'd like to get this done before the New Year's Eve and
No,
start the
absolutely.
year.
Yeah, of course. Hydra's always way behind you, so it's not coming out anytime soon. But I'm just saying that there might be some ideas that maybe you can borrow from
Mhm.
Hydra Zoa a little bit later on to allow you to have more convenient batch or just concurrent or parallel even deposits and withdrawals happening.
Yeah, but how do you solve the thing? For example, you don't need to observe something happening on layer 1, right?
Well, I need to observe that the deposits happen, right? So they need to have sufficient block depth on layer 1 before the off-chain protocol is allowed to consider including them in the L2 ledger, right? Other than that, I don't really need to observe anything on layer 1.
Okay.
Yeah.
Well,
And
actually,
withdrawals as well, since they're just simple native script transactions, I don't need to observe them either, right? Because it's deterministic. All that matters is that the transaction is submitted, or the sequence of transactions corresponding to a snapshot are submitted, and then I don't have to worry about the rest.
yeah, in our case, or at least what I understand, why is it a two-step in Hydra? Is it because, as Sasha mentioned, you are gonna propose to decommit something from the head that is gonna come into a signing of a snapshot, and then you're gonna post the decrement. And the moment you post, that changes the state on chain, and now everybody that doesn't observe that transaction happening on chain, they are still unaware of what happened with the decommit. So they may attempt to close the head using the previous UTXO without the decrement happen. In that case, that's why we keep the UTXO hash in the datum, so that you can check whether it's an honest close from a party that has an old snapshot, just the one before, which has to be the version -1 specifically at the same time. So, and then when you close it, the FANA will take care of completing all the decommits if there is any pending. That is the scenario from my understanding. Why is it a two-step? So
Yeah, that makes sense. Yeah, it totally makes sense within your context. Within my context, I don't need to do that because for my snapshots actually have a deterministic plan, right? A sequence of transactions that are actually multi-signed directly by the consensus parties. That deterministically releases all the withdrawals, and that's mandatory, right? And those settlement transactions are deterministic because the off-chain protocol will never contradict them in any future snapshots. And in fact, if you want to close a Hydra Zoa head, first all the settlement transactions must be executed, or at least the subset of settlement transactions that produces the latest state UTXO for the head, right? It must be produced, and then you can close.
Exactly, that is the difference. We can close at any moment, or regardless whether you have seen it or not happen. That's the difference in use case we have.
Yeah, right.
Anyhow, it's a really good point what you have raised. It's something we have been discussing during the week about all these hashes being a bit inconvenient for use. The reason is exploring increments, having these two hashes would make it more easy to follow as for how was done for the decommits. You can imagine, right? To Yeah, we first want to come up with the most naive approach and then optimize on top. We are just finishing about the exploration to start, and then now we need to, probably unify these two UTXOs. But at the same time, it's important to mention that in our case, we don't have like a queue of pendings deposits or a queue of pending withdrawals. Instead, there at the moment can be only one pending, either a deposit
Right.
or a settlement. That's important to know. I would like to know how did you manage to group several increments, if they are heterogeneous or not, and how did you manage to have them sign in advance before the action happens? That's really interesting. If you would like to share.
Yeah, I'm currently working on the updated version of my white paper, and it's quite different from the old one that you may have seen from 2 years ago, right? In particular, I'm leveraging basically native scripts all over the place, except when consensus breaks down. In a way, that's kind of necessary for me, because this determinism that I described is kind of an all or nothing situation. Because if you're relying on determinism and you have multi-signed transactions within this deterministic sequence, then you can't have any UPLC scripts, because UPLC scripts require collateral, and collateral cannot come from a multi-signed UTXO. It can only come from a single pub key UTXO, which means that whoever holds the collateral can invalidate the any of the multi-signed transactions that use UPLC by simply spending the collateral, right? And so that's a no-go for my purposes, which is why I've had to figure out a way to basically turn all of my transactions, the ones that happen within a normal flow when consensus holds, all of them must be native script only, right? They're not allowed to have any UPLC scripts, right? And the only time when I can have UPLC script is when consensus breaks down and I have to shift to dispute resolution mode. So that's kind of the general idea. That's the main difference, I think, between Hydrazoa and Hydra, right? This shift to native scripts and a drastic reduction in on-chain, state machine kind of mechanism, right? I'm leveraging determinism to replace that.
I see. I understand. Yeah, you go less frequent to layer one, correct?
No, potentially more frequent, because I have settlement transactions. So every snapshot will have one or more settlement, or can have one or more settlement transactions. If this snapshot recognizes any deposits that have been made on layer one, or is releasing any withdrawals events that is recognized since the last snapshot, right? Then it must have corresponding settlement transactions that will absorb those deposits and release those withdrawals, right? And so those settlement transactions are a chain of one or more, L1 transactions that execute all this. Probably in most cases, it would be a single settlement transaction, right? Because there's probably not going to be that many deposits and withdrawals per snapshot, because these snapshots are produced pretty frequently. But it can be more, so that I don't have to constrain the number of withdrawals and deposits that a snapshot can handle, right? So this happens pretty frequently. And also the timeout mechanism that I'm using to transition to UPLC if consensus breaks down kind of requires me to, once in a while, I have to do a sort of no-op settlement transaction that just increments the version number but doesn't actually absorb any deposits or release any withdrawals, mainly to kind of reset the timeout so that it doesn't trigger because consensus still holds.
Interesting. That is really interesting.
So it's basically the same idea as the timeout for deposits, right? So deposits work the same way. you have a UTXO that's been sent in by the user, and this UTXO can be absorbed by the head, but there is a timeout mechanism that allows that UTXO to be refunded back to the user, if the head doesn't do what it needs to do, right? The head state works the same way. The head state can be evolved to a new head state, right? If a multi-sig transaction comes in to do it, but if it doesn't, then there's a timeout mechanism that transitions it to the dispute resolution mode, right? So they're very similar in this respect. And the trick for the timeout mechanism is basically, so I don't know if you guys are aware of SIP 112 observer scripts, but once observer scripts are available, you can actually have a branch in a native script that requires a UPLC script to be present in the transaction, right? And this is my hook. This is how I can get UPLC in the picture, right? Because I can say that after this time, I allow the UTXO to be spent if this observer script is present, right? And I don't need to, and this can be an alternative to the usual multi-sig requirement to spend the UTXO. Before SIP 112 comes to mainnet on Cardano, I do the same thing, but I use post-dated transactions. So essentially, I have a post-dated transaction that's multi-signed, right? And that acts as a fallback. In case the normal thing doesn't happen, the post-dated transaction can be sent in, and if the UTXO still exists the way in the same state, then it can be spent. Sorry, that was a lot of text. Does that make sense?
No. You lost me a bit. I'm not gonna lie, but at the same time, I start to think I start to dream about. I remember Sebastian playing around the idea of inception, and he managed at least to have a Hydra head over a head, simulating a head as a chain with ticks and so on. And I wonder if you can run Hydra SOA on top of Hydra, and you don't need to do this PLC switch. I don't know. And every touch to the layer one actually is to Hydra, and perhaps that could be interesting.
Yeah, for sure. There's a lot of flexibility here, right? You can run Hydra ZOA within Hydra, Hydra within Hydra ZOA, HDLCs between Hydra and Hydra ZOA, or between Hydra ZOAs, HDLC between Hydra ZOA and Bitcoin Lightning, HDLC between Hydra or Hydra ZOA and Midgard. There's a lot of opportunities.
What a time to be alive is going to be in a few years, right? Sounds really
absolutely. I'm actually writing a little paper right now about this kind of HDLC based interoperability between Hydra ZOA and Midgard, right? But of course, you can kind of replace Hydra ZOA with Hydra, and most of the statements apply in a very similar way, right? Because Hydra ZOA is an evolution of Hydra. So yeah.
Crazy. I also curious. I'm sorry for driving the discussion to this, but currently there is a known issue on Hydra about trying to close a head where there is a very big UTXO. We need to work about fanning a big UTXO partially in several steps, and I wonder how are you dealing with that in Hydra SOA? Are you just treating the fan out as a sequence of the withdrawals? That's for you the fan out phase?
So while consensus still holds, I'm able to withdraw an arbitrary number of withdrawals because already I have pre-built the mechanism to have a sequence of withdrawal transactions, right? So essentially it's not a sequence even, like you can think of it more as a tree, right? So every settlement, like every time you increment the version, the major version, you kind of have a tree growing out of that version that releases all the withdrawals, right? And that tree is basically a fan out tree, right? And so I can release as many withdrawals as I want, and there's complete flexibility in doing so because it's just a matter of how many settlement transactions am I asking all the head parties to multi-sign, right? That's all it is. For fan out of a like a head that's been halted, right, where there's a Merkle root, that's a little bit more tricky because you basically every withdrawal needs to show a Merkle proof, right, for everything that's being withdrawn, and needs to either modify the tree in place, right, and so you'll basically have a different root hash coming out of every such withdrawal action. It's actually not too bad because the Merkle Patricia Forestry library in Icon can actually handle a whole bunch of Merkle proofs very efficiently in a single transaction. So that can be done, pretty simply, and in fact, that's probably that's what we're going to use in Midgard. But also, perhaps you can fan out, kind of not a leaf, but a kind of a non-leaf node, right, containing a bunch of leaves within it, and that allows you to do this kind of fan out more efficiently, perhaps for a whole block of UTXOs at once, something like that, maybe.
Something to explore. Sounds like an interesting idea. All right.
Yeah.
That was fun. That was interesting. Yeah. Definitely, we're going to be working on these hashes. And I wonder. I had a question. Like, your confusion started some versions ago when we released the decrement, or is your headache just started the moment we introduced these work in progress increments?
Oh, no. So to be clear, I'm not arguing for removing the hashes necessarily, because within your paradigm, they might be strictly necessary. I'm just saying that yesterday, when I was reading the your white paper, right, or your technical spec, I just found the way that the paper explains the various news and deltas and alphas and stuff was a little bit hard to follow. So it's more about how the white paper describes it and explains it, as opposed to me questioning the mechanism itself. Does that make sense?
Awesome. Yeah. That makes sense. I agree with you.
Yeah, we'll improve on that, because I think now with this new approach, it's going to be a bit more explicit and less confusing, exactly what I'm going to do.
And about having 4 type of redeemers, I don't know how are we gonna do it simpler. There are actually these 4 cases in our scenario, and but we need to make it much clearer. It's really confusing even for me. We also having this discussion where while doing testing and so on about in which case the model is, and in which state the bad actor is, and the conflict, and so on. It's really, I agree with you. We sometimes it's really hard.
I think you need more human language, in the spec to describe the different things, right? So this redeemer, this is the mathematical definition of it, but also this is what it's for, right? This is its purpose, and this is when a user when someone should use it.
Yeah, I need to be really, really honest with you, brutally honest. We went back and forth at least twice already with these namings, and it's a pain in the neck because every time you change it, you need to, boom, there is a lot of test documentation and so on. And I mean, I'm not saying we are not going to, we need to, it's a tech debt we have. But we have gone so many times back and forth, and I still believe it's been not so good. It's a shame on us.
Yeah, no, I totally.
But it's fun. It's fun.
I understand your pain. I've been living this nightmare.
Yeah.
For the past couple of months. I mean, it's like ages now, and
I know, and sometimes like what happens, also is probably in this other version, without the renaming, maybe there was some simplification while doing so, and we have gone sometimes back because in that version, something was working that right now is not. These are also very funny.
Maybe.
Yeah. But anyway, funny stories about the daily, and but definitely we need to improve on that, and it's something we plan to. We just need to get like some minors. I mean, not minors. Some final workarounds about our test suite to properly cover all the incremental feature, and then we're going to take special care on having all these much better explained and so on. Thank you so much for pointing that out. You're very good.
Yeah, of course.
And well,
Aaron, are you part of the IOG Hydra team, or are you one of the people building applications on top of Hydra?
I suppose technically neither. I just part of Intersect is head of infrastructure, and we were thinking about potentially the use cases for Hydra and seeing if we could do something with it.
Are you on any Intersect committees?
I'm not part of the committees, but I report in to them, if that makes sense.
Okay. Do you have any questions or anything for us? Like any information that you need to help you more effectively inform Intersect about kind of the developments happening on the scalability side?
No, I think I grasped the majority of it. But I'm just trying to join the calls as often as possible just to keep up to date as well.
Yeah, for sure. And I mean, if you do, occasionally have any of these questions, please don't hesitate to reach out. All our emails are in the chat here, and each one of us can speak about our own protocol. So obviously, the IOG team can speak about IOG, the Hydra project. I can speak about Midgard or Hydrazoa. Pi can speak about Gummy Worm. Kaina can speak about what was it called? MuGraph, I think it was called, right? And so on. So we're definitely here to answer your questions if you need them.
Yeah, sounds good.
Cool. All right. Well, thanks everybody. I gotta go, but it's been a pleasure to connect with you guys again. And see you in a couple of weeks.
See you in a couple of weeks, man. Thank you for sharing. Have a great one.